not times, sorry, although you can multiply by constant. Because if you have times 2, then, we're already in undecidable territory. And you can index it to the sequence. Any first-order statement like that, you can just write it down, and it will be automatically translated into the set of all n for which this holds. Even more, we can find something called a linear representation for the number of such n. What is a linear representation? It is a product of matrices with a vector on the front and the end, and these particular matrices correspond to the Fibonacci representation of the number n. So, just to give you a quick example, here's the square of length 2m beginning at position I. It's for all j less than m, the letter at position I plus j is the same as the letter at position I plus m plus j. We can also write down a predicate to say that this block is the first occurrence of this block. So there it is. Since I'm running out of time, I won't say much more about that. And finally, you can write down a predicate that says this block occurs entirely within the nth Fibonacci word, namely I plus 2m is, I plus 2m is less than or equal to n. You put all those predicates together, you get the linear representation. From the linear representation, you find a minimal polynomial for the matrices. From the minimal polynomial, you get the roots. From the roots, the fundamental theorem of linear recurrences, you get an expression in terms of the roots, and that gives the same formula that we corrected that was in the paper of Frankel and Simpson. So all purely mechanically, my student is putting the final touches on the software now, so it will be publicly available. If you want to make an assertion and see whether it's true, you just type it in and it will come. So, long live Neil Sloane, and long live the Encyclopedia of Integer Sequences.
We have about 3 minutes for questions. Anyone?
Yeah.
Your 11,000, your sequence that was long on the 11,000.
Right.
If I recall correctly, those terms were increasing very fast.
Yeah, exponentially, right. So the 11,000 term had on the order of 11,000 digits. So.
Oh, that's all? Oh, I thought it was going to be much more.
No, it wasn't doubly exponential. It was just exponential.
Okay.
But had it been doubly exponential, all you would have to do is compute it modulo some small pi.
Oh, okay.
And you would have been.
So it doesn't satisfy the recurrence.
Right.
But does it satisfy something else?
Nobody knows. It might satisfy a larger recurrence.
We should have very close roots.
Right. Exactly. Yeah. And so it's going to be, maybe some linear recurrence of order 500 or something, whose roots are very close to. Yeah.
So you could do that on various primes. It's going to be an easy.
You could, yeah.
But you would have to include at least 11,000 terms to test.
Yeah.
So is there an estimate for the minimal number of terms?
No, nothing. Yeah.
Are you going to put your slides on your homepage?
Yes. Yes.
Like that? Thank you.
Any other questions? Okay, thank you again.
Thank you.